Alright, so when we're dealing with a problem like this, what we're going to be doing is taking a look at the situation. I'll draw a little diagram here. And what we're going to have is we're going to have a crucible, we'll have a lid, and inside here we'll have some hydrate. So I'd say that's a crucible, lid, and hydrate. And then we're going to heat it, and we'll end up with a little bit less now, and that would be crucible, lid, and anhydrous salt. Now the anhydrous salt is going to be less mass than the hydrate. The hydrate has the water in it, the anhydrous salt doesn't. So to get the mass of the water, what you would want to do is get the mass of the crucible, lid, and the hydrate, and subtract out the mass of the crucible, the lid, and the anhydrous salt. The difference there is going to be the water. In this case it's going to be 1.8524 grams. This is for number 6. If we want the mass of just the hydrate itself, what we'll do is we'll take the mass of the crucible, lid, and the hydrate, and we'll subtract out the mass of just the crucible and the lid. This is going to be 4.7671 grams in this case. Alright, so we're just looking at number 6 up here. We're using this data. If we want the percentage of water, and that's what we're looking for here, it's going to be the mass of water, which we've already got, divided by the mass of hydrate, and that's multiplied by 100%. So that's how you're going to get the percentage of water. We'll need this information to be able to do number 7 as well. So give me a second here and I'll just delete the stuff I've got on the screen. And we'll go through how you might do number 7. So what I would do there for number 7 is I would first of all find from this data, get the percentage of water, and again we do the same thing. We want to find the mass of water divided by the mass of the hydrate, and all of that's going to be multiplied by 100%. So what you'll look at here is we want to also be able to find the percentage of water in this whole molecular formula. So the percentage of water in this molecular formula will be found as follows. So this is the percentage of H2O in MnO3,3.X-H2O, and this can be done for any hydrate where the value of X is known. But it would be done like this. It would be X times MW of water. So it's the molecular weight of water, which you can get by taking 2 hydrogens and an oxygen and adding them together. And then that would be divided by the mass of M plus 3 times nitrogen plus 9 times oxygen, and then that would be added to, again the same thing we've got up here, X times the molecular weight of water, and all of that is going to be multiplied by 100%. So I guess your next question is going to be, well, what do you do for X? Well, you're given a hint here. You're told that X is between 6 and 18. So what I would do is I would plug in the value of 6 and 6 down here as well and figure out what percentage that is. And then, so this is x equals 6, then x equals 18. And then I would see which one of those was closest to the percentage of water that I got up here in this answer. And then you can sort of zero in on it. You know, if it's closer to the value you're getting for the 18, then you know it's going to be closer to the 18. And eventually you'll be able to zero in and figure out what the value of x is going to have to be in order to match what you're seeing there.